Hey everyone. So in this video I will show you how to get a temperature distribution in a 2D plate. So for that, first of all you need to open Ansys Workbench and you will see this kind of white window here. So in that you have to double click on this Fluent. So here you can give any name that you want for your project. I am keeping it as it is. Let's start with geometry. So click on geometry and just click on this Z axis and XY plane. Now go to sketching and select a rectangle here and just draw one rectangle. Then we have to give dimension to this rectangle. So go to dimension, select horizontal and select these two edges and keep it over here. Then go to vertical, select these two edges and keep it over here. After that you can change the dimension from here. I will take a 1 meter by 1 meter computational domain. So you can see it has changed now. And now click on this fit to screen window and you will get this kind of thing. So if you want to move these dimensions, then you can select this option and you can move the dimensions and once again press fit to screen. So now we have to create a surface from this sketch. So for that, go to modeling and go to concept, then surface from sketches. So for that you need to select select whole sketch. So that you can select from here. Just click on this sketch one and apply. So you can see the whole sketch has selected and click generate. Now this surface has been created from the sketch which we created. So geometry part is now over. You have to save your project. Click on save and create one folder or something. I'm keeping it as a new folder and in that just give a name like 2D temperature distribution and save it. So your whole project will be saved there. Now go to mesh. So same way here also click on Z axis. So now if you click on mesh and just generate mesh, then you can see the mesh is not like structured mesh. It is not a it is homogeneous but it is not structured. So if you want to get a structured mesh, then you have to right click on mesh, you have to go to insert, then sizing. So in sizing you have to select all four edges. Here we will use edge sizing. So select this edge icon over here and select all four edges and press apply. So as you can see here it will show four edges. We have selected four edges. Now keep a number of divisions here and give number of divisions say 40 and just click on mesh and update. So once again you will see it is not a structured mesh. So once again you have to click on right click on this mesh option and then insert and mapped face meshing, and in that you have to select a face. I will select this face and apply, and once again click on mesh and update. So now you can see we have created a homogeneous structured mesh, and this mass statistics you can see from here. You can check its aspect ratio from here. It should be nearer to 1. Then you can check skewness from here. Skewness should be nearer to 0. Here in this case it is like 10 to the power minus 6, 10 to the power minus 10. So orthogonal quality also you can check. We are good to go. Just close this window. Sometimes you will not see this right click over here, so just right click on the mesh and update, so it will get updated and you will see the right click here. And now go to setup. Okay, one thing we forgot, in meshing part itself you have to give name to all the edges, because we have to apply different kind of boundary conditions. So just select this edge. First of all, take this edge icon, and select edge and right click, then create named selection, right left all or something. Okay, then you will see name selection left all. Then select this edge, create name selection, right wall. Okay, then select top wall, go to create name selection, then right top wall. Okay, select this edge, right click, create name selection, bottom wall. Okay, once again click on generate mesh, then close it. As you can see here it is showing like this, so you have to just right click on that and update. So now setup part, let's open it. Here you can see processing. For processing you have two options, parallel processing and serial processing. Parallel processing is used for PCs which are connected by server. Here you can give GPU, number of GPU per machine and processes. So this parallel processing is used to increase the computational speed, but here I am using a laptop only, so I will use serial processing. And you can give double precision over here, but for this simple problem we don't need this double precision. Just press OK. So let's start with the scale. So in scale you can change the unit type. So if you are selecting centimeter, then just unit will change, dimensions will remain as it is. I am keeping it in meter only. Close, press on this check button, and you can see the volume statistics and face area statistics. So this volume, that should be positive. If you are getting any negative volume here, then you have to change your mesh size. And click on this report quality. You can check once again orthogonal quality aspect ratio. Then display is to show this computational domain over here. As you can see, I have selected all the things, so all the things is shown here, all the things are shown here. Let's close it. And here I am selecting pressure based solver because density is constant. I'm taking it as a solid material. So you can do transient analysis and steady analysis. In our case it is a steady analysis. Here 2D planar, absolute velocity formulation. Then gravity, if you want you can turn it on, but in our case it is not required. So go to models, go to energy equation only we require. I will turn it on. Then I will go to material. In that, by default it will show aluminum as your solid material and air as your fluid material. But you want to add some new material, then you have to go to create and edit and Fluent database. In that you can select a solid. Suppose I want copper, then select copper, copy, close. So as you can see, copper has added here in the solid materials, and you can change its property. If you want a specific properties, then you can change it from here and change and create. You have to click on this button and close it. Now you can delete this aluminum, but here it is showing that it is still in use in porous material by surface body. So as of now you cannot delete this aluminum material. We will keep it as it is. So I will go to cell zone condition, then I will select solid here. Okay, and in that I have selected, I have means it has already assigned, copper has already assigned to the surface body which we want, and then press OK. Then we have to go to boundary conditions. In that, first of all, bottom wall, go to edit, then thermal. In that, temperature, suppose I want 330 Kelvin temperature for the bottom wall, then select temperature 330 Kelvin temperature. Here don't forget to change this material, copper, press OK. Then go to interior surface body, edit. Here it is showing the interior surface body, press OK. Go to left wall, edit. Suppose your left wall is adiabatic, then for adiabatic you have to give surface heat flux value as 0, so it will automatically take it as a adiabatic, and press OK. Then right wall, select right wall, edit, thermal. Suppose your right wall is at suppose 400 Kelvin, change material to copper, press OK. Top wall, edit, thermal. You can give convection boundary condition also. For that you have to give a temperature of surrounding medium as well as a heat transfer coefficient. I will just simply keep heat flux value. Suppose I am keeping 100 watt per meter square heat flux and copper material, and press OK. So we have given 4 different boundary conditions to 4 walls, and this boundary condition value is important. You have to check it once again whether it is correct or not, especially this material part. This material should be copper only in all case. Okay, so dynamic meshing we don't require it. Reference values, reference value you can give surface body or interior surface body, so according to that it will take this reference values. Reference zone you can take surface body. Solution method, we don't need to change these methods to solve the problem. These factors also we don't need to change. Monitors, we don't need any monitors. Then go to initialization and hybrid initialization. Just click on hybrid initialization, and hybrid initialization is done. Then go to calculation activity. Here if you are doing transient analysis, then you can save your data by some number of time step, but for iteration process we don't need to save every iteration, we just need last result. So I am not changing this thing here, and run calculation, click on check case. If you see any kind of message here, if you see mass needs to be checked, then just go to mass and check, and once again check case, and you will see no recommendation to make at this time, press OK. Then you have to give number of iteration. Let's see, we are giving 100 number of iteration, and if more number of iteration are required to solve the problem, then we can give it afterwards. first of all I am keeping 100 number of iteration and calculate. So as you can see, in 5 iteration only our solution has converged. So press OK. Then go to graphics and animation, count tools, then setup. Then go to temperature contours, static temperature, and just press display. So as you can see, these are your temperature contours. You can increase the number of contours from here. Suppose I am keeping 100 and display. So as you can see, it has changed. Number of contours has changed. And you can give fill also, and it will show filled part of 2D temperature distribution. And in that, suppose you want a temperature at the midline, which is going from left wall to right wall. So for that you need to create one line that you can create from here, line, and just give x value 0, y value x1 value 0, x0 value 0, x1 value 1. Then y is your 0.5 for both points, which is a mid y line. Then create, close it. So here you cannot get a temperature, just close it. Go to plot and xy plot setup, then go to temperature. Here you can select a curve length, then mid y line and plot. So as you can see, it will show you the temperatures. Left wall is at 400 Kelvin, which is the boundary condition, and right wall is 355, around 355 Kelvin. So if you want to export this plot into your work, then you have to select this, write to file and write. Just select a folder in which you have saved this data. In that, keep the name as a file name and press OK. Okay, so now close it and open Excel. In that, go to file, open. In that, computer, browse, documents, new folder 2. Here select all files and file name. So it will show you this kind of message. Just press yes, then press next, 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 finish. So you will get value of x coordinate and according to the value of the temperature. As you can see, this will be your grid points. Every grid point you will get one temperature. At every grid point you will get one temperature. Okay, so and from this value you can plot the temperature distribution along mid y line. Okay, like, share, subscribe. I will be uploading more videos for Ansys Fluent tutorials in future.